Thank you, and good morning again. We're going to talk about some work that we're doing around permafrost on the highway, building on a lot of the things that you've heard already. The presentation by Richard introducing problems along the Dempster is a really good starting point for this. It gives you a good perspective on what's happening in the Yukon. This is one of our favorite pictures to pull out as part of this project. It shows Paul Murchison, who's from Highways and Public Works. And Paul is not a small guy. He's kind of disappearing in this crack, so it gives you a sense of the magnitude of some of the issues that are happening along the highway. So I want to give you a little bit of context about our transportation network in the Yukon, because we have comparatively many roads. We're pretty big, not as big as some other northern territories. We have about 35,000 people, 17 communities, and a lot of our transportation focused on road and air. We have almost 5,000 kilometers of maintained highways through the territory, and about 25% of those are impacted by permafrost. So those are the ones that are shaded in blue here. So here's the Dempster that you heard about yesterday, and we're working on the northern 200 kilometers of the Alaska Highway. So a lot of people come into Whitehorse, rent RVs, and travel up the highway. This is a really beautiful drive. So here's Haines Junction, Kluane National Park, and really scenic drive here along Kluane Lake. So in the summer, at peak tourist season, there are about 9,000 people through the month of July, or 9,000 vehicles that cross the border here. On average, about 150 to 300 vehicles a day on this highway. And in addition to the tourists that are driving this stretch, you'll see this is the only all-season road to interior Alaska. So it's important for transportation of goods, for access to medical services, and yeah, well-traveled piece of road. If you have the chance, if you haven't been up there and you have the chance to go, it's well worth it. But impacted by permafrost. So see, these are some of the things that we see along this highway, similar to what you saw yesterday along the Dempster. These are pretty, this is pretty significant, especially when you're driving along that road in an RV. It can be pretty bumpy. And an example of a thaw slump adjacent to the highway. So we're not looking only at features that are impacting the highway and the embankment itself directly, but also adjacent to the highway. So the highway's running just along the top up here. Probably similar to other territories, but for us in the Yukon, maintenance costs are about 10 times higher along permafrost stretches than along non-permafrost stretches. And because 25% of our roads are underlain by permafrost, it's really important for Highways and Public Works to make good decisions around the way that they spend money on maintenance and upgrades to the highway. So with that in mind, we entered into this project in partnership with Highways and Public Works for the government of Yukon. We applied for funding for a 3-year project and got it. And so the objective is to characterize the sensitivity of permafrost under the highway to thaw, just working on this northern 200 kilometers of the highway. And to use that characterization to provide information to Highways and Public Works to help them make informed decisions around their maintenance and repair process. And again, as we're doing with our hazards mapping project, we're incorporating projections of climate change so that it gives a little bit of future context to the work that we're doing. We're taking a few approaches to this. We're spending a lot of time compiling existing information, pulling together official geology maps, doing some air photo interpretation, getting a lot of the information that Highways and Public Works already has. They classify road conditions along the highway as good, moderate, or poor, so we have some historical information captured that way. They do a lot of geophysics along the highway, so we can put all that together as part of the work that we're doing. We're doing our own geophysics, so some examples of some ERT profiles that Fabrice and Louis-Philippe and others did along the highway this summer. We are installing monitoring, so we're drilling boreholes, putting in ground temperature cables, putting up met stations, doing some snow monitoring along the highway. We'll set that up and then hand it over to Highways and Public Works at the end of the project for continued monitoring. We're doing drilling, so we're using hand augers to drill permafrost cores. We're also doing water jet drilling to deepen our boreholes. And as you can see, and Fabrice will talk about this more, we have a lot of really ice-rich permafrost. And then we're also doing analysis of the cores that we collect in the lab at the research center. So that's a really significant part of this project. We can use that to analyze ice volumes, settlement potential, stability of soils in response to permafrost thaw. So I'm going to hand it over to Fabrice.
So in this project, what we are really looking for, it's, okay, mapping permafrost, but we have a special focus on the ground ice content, because that's what is the problem in permafrost when it thaws. And we also have a look in ground temperature. The warmer permafrost will degrade sooner than a permafrost with a colder temperature. And we're also looking at the permafrost thickness. Obviously, 40-meter thick permafrost will take longer to degrade than 10-meter thick permafrost. So we use coring, we used to sample permafrost, and we have ground temperature monitoring, and also we do a bit of geophysics and electrical resistivity tomography along the highway. This picture of Google Earth shows the 20 sites that we have surveyed so far, and we have sites where we only just cored boreal, the site in blue. Other sites where we have cored boreal plus put some temperature logger, and some other sites where we have the sampling, the temperature monitoring, and also the geophysical survey. As you can see, there is a more important concentration of dots in the northern part of the highway. It's the part where the concern and the degradation are more important. If we have a look to the temperature we have so far in permafrost, you will see that we are like relatively warm, less than -2 degrees temperature just before Beaver Creek. And then when we arrived, in this area, we start to have colder temperature, so a colder permafrost. And we try to understand also the history of permafrost along the area. And during the past glaciation, this area was completely glaciated, and this one was not. So we try to understand a little bit about the history, the dynamics of permafrost. And probably these temperatures are colder because the permafrost is older in this area. So this slide show you an example of what we are doing when we core permafrost. So you can see that you have quite a lot, in this sample we have quite a lot of ice occurring all along the core. And the kind of analysis that we have done on this one was to measure the volume of excess ice and also to have a grain size characterization of the sediment. Now I give you an example of a specific area along the highway. This is north to Beaver Creek. And we have three survey sites, and I will focus on these two sites that occur in a valley bottom, in a fluvial, ancient fluvial system. And it is a relatively new area. You can see that it is a road, and this was the ancient road passing by. So they just make the road more straight for the drivers. And it is an area with a lot of problems. They rebuild it completely this summer. One of the sites, we have a met station. So we have ground temperature, but also wind direction and speed and atmospheric temperature. this we used for this site pipeline borehole. So there was a survey for the Alaska pipeline in the area, and they made some boreholes, and they left the borehole with PVC pipes in it, and we have access through the geological survey to some of the borehole, and so we have one cable in one borehole, and the geological survey has another cable in one other borehole, and we have the logs of these boreholes, but we made a confirmatory drilling also in the field. And this huge ditch was part of the renovation made this summer to collect the water far from the road. And what the logs from the Alaska pipeline borehole say is that we have a lot of silt, so fine sediment, and we have also relatively important ice content, volumetric ice content deeper in the profile with clay. So it's like very fine grained material, very ice rich. What the borehole log does not show is that you have a ice wedge network in this area. You see, when they made the ditch, we were able to see the ice wedge, and we also cored some of the ice wedge when we were drilling. So you see that it is like very pure ice, and it's on a very significant thickness. Sometimes 1 meter, 2 meters of ice, pure ice. So if you look at the ditch, you see here is the ice wedge showing up. It starts to be eroded by the water flowing in the ditch, and the ditch is collapsing on the side. So we walk the ditch and we see ice wedge showing up all along the ditch. So there is that all along the highway on this section. So we did electrical resistivity tomography. And these are just the first results. And we see that we are very resistive in this area. And all this is permafrost. So we have permafrost at least to 40 meters. It's a 230 meter profile. If you see here, we are less resistivity. You have less resistivity. We have an influence here from the creek passing by. So far what we see is like, it seems all permafrost is probably, this is very resistive because, maybe it's because it is colder, but also maybe because it is very ice rich. And it seems to be like that at least for 20 meters. On the other side, this time we had only 100 meter, 115 meter profile, so we go less deep, but it's very similar. We have also this very high resistivity material. If we look at the temperature, well, we have relatively colder permafrost with temperature above, below -3 degrees. And so that's just the temperature we collected in August and in October. We will need a full year of record to be able to try to project the ground temperature profile. But if we make an attempt with this one, we see that permafrost might be deeper than 45 meters. So obviously it's a site with a lot of ice, a lot of ground ice. Permafrost is very thick, and there seems to be a lot of ice all along the profile. So it's degrading right now. It won't stop for some time. Another thing that we are doing too is a snow survey to measure the impact of snow on the embankment. So we are putting loggers at the ground surface, and we will come in winter to measure the thickness of the snow. And so that's it. That's the kind of stuff we are doing and the kind of results we have.
So I just want to come back again to tell you a little bit about the communications that we're doing around this project, because we are channeling some of our efforts towards this, as we're doing with our hazards mapping project. We had a lunch at Buckshot Betty's in Beaver Creek, and Fabrice and Mohammed Idris from Highways and Public Works went and presented this project to folks in Beaver Creek and the White River First Nation there. We are having regular meetings with Highways and Public Works to keep them updated about the project and to give them the opportunity to fill us in on what they've been doing along the highway, and also really to make sure that what we're doing is tailored to their needs. So we'll spend a lot of time working with them, figuring out the best way to deliver these products, the outputs of our project, whether that's a guide for folks actually at the highways camps along the highway doing maintenance, reports with all of our geotech information. It's important for us to work closely with them to figure out the best way to deliver these results to them. We did a postcard about the project that's on the table outside that we put in the visitor centers at the border of the far end of the Alaska Highway with our favorite picture of Paul. We had CBC out in the field with us, which was really fun. So Fabrice is a good teacher, so he taught her everything she needs to know about permafrost, and she did a nice segment for us. Fabrice has talents beyond just working in permafrost, which he's putting to use here, developing videos for us. So the videos are intended to capture what kinds of issues we confront when we're in the field, what kinds of questions we go to address, and the tools that we use to address those. So we want to bring these into schools and post them on our website and use them to describe what we're doing in our project. So we have a draft. I'm not sure if we're going to have the chance to show it while we're here, but it does feature young permafrost researchers pole dancing with a water jet drill, so it's really worth checking out when we put it online. And then the other thing that we're thinking about is outreach to travelers along the highway. So we really want to make sure that we're not just, because we know that a lot of people who are driving the highway aren't from the communities that we're working in, we want to convey the results to them. So one of the ideas that we had was to build placemats, maybe modeled after a hazards cartoon, that we put in restaurants along the highway. And then the other thing is to develop placards about permafrost, so people get a little bit of a chance when they're stopping at rest stops to admire the views, to learn about permafrost and what they're driving over as they're going along the highway, and then what kinds of things Highways and Public Works is doing to manage and adapt to changing permafrost. And again, like to really acknowledge the contributions of our partners and our funders in this project.